Multicast routers, where multicast is one to many, create distribution trees that enables the flow of traffic from source or from the RP to reach the receivers. The range of addresses that can be used for a multicast group is from 224 all zeros through to 239 all 255s, with 239 all zeros to 239 255.255.255 being allocated for private use, with each individual multicast address representing a group that the receivers can then request to join. Now, a distribution tree represents the path that multicast takes through the network between the sources of traffic and the receivers. And on the Nexus platform, you can build different multicast distribution trees to support different multicast technologies. The first multicast distribution tree is the source tree. Now, the source of the multicast traffic is seen as being the root of the tree, and the receivers are located at the ends of the branches. The multicast traffic flows from source to receiver using the multicast forwarding table and S,G entries. The multicast traffic takes the shortest path from source to receiver, hence source trees are also commonly called shortest path trees, which is SPTs. Now, it's good to know that a separate source tree exists for each source that is transmitting multicast packets. However, on the Nexus platform, we're going to be using shared trees, and these differ from source trees in that the root of the tree is a common point in the network called a rendezvous point, which we'll call an RP. Multicast sources transmit their traffic to the RP, and receivers join the RP to learn of active sources for their required group. All sources for a particular group share the same tree, so entries for a shared tree use the *G notation. Guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the Play Special. Do you want to know what the Play Special is? Press like and subscribe. Okay, back to the video. Now, when a receiver wants to join a particular multicast group, it uses something called IGMP. There are 3 versions of IGMP, but only versions 2 and 3 are supported on the Nexus platform. Version 1 is obsolete. Now, we're going to need to use a multicast routing protocol so that the routers can locate and request the multicast streams from other routers, and we'll be using PIM for that job, which is Protocol Independent Multicast. And PIM will be operating on top of the existing IGP using the existing unicast routing table for path selection. PIM can operate in 2 modes, dense mode and sparse mode, but only sparse mode is supported on the Nexus platform. But let's take a quick look at PIM dense mode just so we get a complete picture. PIM dense mode is used when most locations in the network will require the multicast feed. So multicast packets are flooded everywhere, and then pruning takes effect, which discontinues sending the multicast traffic to devices that don't need it. PIM sparse mode. Unlike with dense mode, PIM sparse mode operates on the assumption that recipients for the multicast group will be spread throughout the network, with the majority of devices not requiring the multicast feed. Devices have to request the multicast feed with a PIM join message, and this join message is then sent towards the source, or towards an RP, based upon the unicast routing table. The join message basically states, "Oi, we want the multicast traffic over here," and helps the router connect to the shared tree for that multicast group. Now, an important concept with IP multicast is that of the RPF check, which is the reverse path forwarding check. Unlike unicast routing, which is based on the destination IP address, with multicast we care about where the source address is. Routers build multicast trees to find the best path from the multicast receivers back to the source. Then each incoming multicast packet undergoes an RPF check to verify it was received on an interface leading to the source, according to the unicast routing table, which is determined by the IGP. If the packet passes the RPF check, it is forwarded. If not, then the packet is discarded. When PIM is configured in sparse mode, you have to choose a router to operate as the rendezvous point. A network can have multiple RPs or a single RP that service all groups. Now, what an RP is a single place in the network which is assigned as the chosen point of a shared distribution tree. This connects the source and the receivers. An RP can be either configured statically or learned dynamically. And we're going to take a look at 3 of those options today. We're going to look at the static RP, then auto RP, and finally we're going to look at PIM bootstrap router, which is BSR. So the first thing that we need to do with this multicast routing lab is we need to establish and I'm going to use OSPF. So let's have a look at the topology very quickly. This is the topology that we're going to be using. We have 4 Nexus switches, Nexus 1 to Nexus 4. Nexus 1 has the multicast attached to it, and Nexus 3 has the Nexus 4 has receiver 2, and Nexus 2 will be the RP. And I have the currently open, and let's do that configuration. I'll do it in a notepad. The only reason I'm going to try and do it a bit quicker is, as you see here, I only have 19% battery left. Notepad. And if we were doing the configuration for 1, I will make in here 15.0.0.1 on a /30. Okay, so let's go. First thing, terminal color persist. I'm sure I don't need this because it's already there. Conf T, switch name will be Nexus 1. Username and password, so username of admin, password admin. Also, we need to enable the features. So the first feature that we're going to need is OSPF. The next one I'm going to need is PIM. Interface E1/1, that's going down to Nexus 2. Let's no shut that interface. Give it an IP address of 10.1.12.1/24. We need to enable it for, so let's just do the OSPF here as well. We also need to enable PIM sparse mode. All right, and then we need interface E1/4, which is going over to the receiver. And we need to do the area on that as well. And then we need a loopback. But we don't need a loopback, but I'm going to put loopbacks on all of them. Also, what I didn't do here on this interface, I didn't no shut it, so let's turn that up. IP address of 1.1.1.1/32, IP router OSPF1 area 0. Okay, that's all I need. Let's try and copy and paste that in. I got rid of all of that. I want to undo that. Is there an undo button here? No. All right. So I have to do all of that again. Sure, again. So for T, Nexus 2, interface E1/1 is going up to Nexus 1. No shut that interface. Area 0. Enable it for PIN. Sparse mode. Only sparse mode is supported. If I just copy this, copy this and paste it twice, and then I can. So the first one is 2. 2 goes down to Nexus 3, so make that 23. And 3 goes down to Nexus 4. So this will be loopback. Oh, we can do any features here. So feature OSPF, feature PIN, and router OSPF1. Okay, IP address of 2.2.2.2, 32. I think that is it. Let's copy that and paste that into Nexus 2. Let's do the same for 3. And we'll change this to 3. And that will be, we can get rid of this. 2 will be 23.3. 4 goes out to 4. We'll make that totally different IP address then. So let's say 25.1.1.3. That looks good. Let's paste that into R3. Into Nexus 3, sorry. Let's save that. And finally, 4. So that will be 3, 24.4, and 4. Let's just make this a random IP address of, I don't know, 172.16.0.4. Make the loopback address of 4.4.4. And I have to remember these IP addresses when I go to the other side. Let's put enter a couple of times in here. All right, let me copy this out and change the name to 4 as well. We don't want the same name. Copy. That's 4. Okay, so I pasted this in the wrong router. So I don't know how much of this will be overwritten, but we'll soon find out. This should have been in 4. Let's paste this. Let's see what's happening. So we need to default the interface of /1. And I'm hoping that is it. We shouldn't need anything else. Let's copy that. And then let's do the configuration for Nexus 1. So what can we use from here? 1 feature pin. This will be 1/1. This should be 12.1. IP original. I think this was 15. So 15.0.0.1/30, not /24. And 1.1.1.1. Let's take that, paste that into R1. Make sure it is Nexus 1 this time. And as a verification, what I should be able to do from Nexus 1, I should be able to ping and that will mean that we have reachability through OSPF. IP OSPF neighbor first. Neighbor. Ping 4.4.4.4, which is reachable. And ping 3.3.3.3, which is also reachable. And then let's have a look in our routing table. Show IP route. Okay, so that's our IGP configuration. Let's now move on to configuration. Going to do our PIM configuration on, I will just open up some receivers. We're looking at our multicast first source. We don't have any configuration on there, receivers either. That configuration quickly. So this is our multicast source. Interface. First thing I need to do, I need to enable IP multicast routing. And then interface G0/0, IP address of 15.0.0.2/30. Also, I need to do an IP route for reachability. And that should be it for our multicast source. Now, with the multicast source protocol to enable multicast group or sending for a multicast group. So let's look onto receiver 1. And I just need to jump onto Nexus 3 to find out what IP address I put there. It was 25.1.1.3/24. So 25.1.1.1 should be okay. I'll just call it host 1. IP address 25.1.1.1. PIM configuration here now. So IP, IGMP, and we're going to say the group is 239.9.9.9. We're also going to, I will add the loopback of as the one-day through point. So IP PIM RP address is 2.2.2. And then do the same on receiver 2. And this is the static configuration of our. There are 2 others. There's auto RP and then there's BSR. But when you're doing static, you have to statically configure the RP address everywhere, basically, and put PIM everywhere as well. All right, so our host name is host 2. IP multicast routing. I think it was 172 over here, 16.0. Let's just call that 100. Am I able to ping 172.16.0.1? No, I am not. So let's look on Nexus 4 and find out what the address was. 172.16.0.4. Okay. I am able to ping that. IP IGMP join the group of 239.9.9.9. Oh, I don't think I've done an IP route on the other side. So IP route 0.0.0.0, 0.0.0.0. the next hop is 172.16.0.4. And also interface the IP PIM RP address of 2.2.2.2. Let's see if it gives me a message about a tunnel coming up. The tunnel chain state down. I'd expect that to come up. I don't know why that isn't, but we could do some troubleshooting. Okay, so first thing, can I ping do ping 1.1.1, and that will show me that I've got reachability. I can. Let me see if I can do that from the receiver. I don't think I could do it from this side because I didn't do the static route. So I do ping 1.1.1.1. Yeah, I need to do the static route over here. So IP route to get to anywhere. Go to 25.1.1.3 was it? Yeah. Let's save that. And IP pin tunnel 0, I think it usually is. And it's down. Why is this down? I'm expecting that to be up, so I should be able to ping from the multicast source, but if that tunnel is down, I won't be able to. So do ping 239.9.9.9, repeat 2. No response. So I've probably missed out some configuration. Let me have a look on Nexus 2. Do show run interface loopback 0. Right, I have not added PIM under the loopback. So interface loopback 0, IP PIM sparse mode so that it can actually be the rendezvous point. Let's see if it's giving me any messages about tunnels coming up anywhere. No. Let's try that ping again though. Still nothing. All right. Do show run interface G0/0. I'm going to enable it here as well. G0/0. IP PIM sparse mode. All right. So now I see the PIM neighbor coming up. So do show IP PIM neighbor. See the PIM neighbor and do show IP PIM tunnel ton 0. Let's see if I could ping. Probably still not. Do ping 239.9.9.9. All right, let's see if I've done the PIM on this side as well. Do show run interface G0/0. Interface G0/0. IP PIM sparse mode. And on this receiver, do show run interface G0/0. Interface G0/0. IP PIM sparse mode. And there's one other thing I need to do, which I just remember. I need to actually define the everywhere. So on these, I will say IP PIM rendezvous point address is 2.2.2.2. I think that's the command I was missing out, mainly. Let's take that and paste it on the multicast source and also on receiver 1. Right, now we should be able to ping. Do ping 239.9.9.9. and we're not able to ping. See if I've got the show IP pin RP mapping. RP. It's not showing the RP here. So do I have that RP listing on the Nexus switches? I probably don't. So let's do that very quickly. IP pin RP address of 239.9.9.9. We can make it just for that particular group. Oh, sorry. It's not 239, that's the group. The IP address is 2.2.2.2, and the group list will be 239.9.9.9/32. That means it's just the RP for that particular group. Let me paste that on all of the Nexus switches. We've got RP mapping. Show IP pin RP. And we do now. So we can see that we have our RP of 2.2.2.2, and it's only the RP for this range of 239.9.9.9. Again, let's try and ping. IP pin neighbor. Do I have all the neighbors there? From R2 would be a good one. Show IP pin neighbor. Show IP en route. Do I have the 239? It has a *G entry. Do I have that on the receiver? Show IP en route. I have the *G and the neighbor, RPF neighbor is 25.1.1.1. It's good. 8% battery. Show IP en route. Do show IP en route. Yes, it looks good. Why am I not able to ping them? Do show IP en route. Ping 4.4.4. I'm able to ping. So do ping 239.9.9.9. Okay. So it just took a while to come up. So we should be getting responses from both receivers. So 25.1.1.1 is good, and 172.16.0.100. All right, guys, thank you for that one. That is it for static run. I'll see you in the next one, which should be auto R.